I'm here because I
Yeah, good. Good to meet you.
Early stage we basically what happens in the market is San Francisco, but also in the Far East. So I think we're all.
If we could have, we mic this up? Well, I'm going to get them in a minute. Hey, Al, how nice to see you. That's as loud as it goes. If we could have everyone take their seats, please. We need to get started.
If you're all right with sharing microphones, you got a lab if you really want to.
So thank you very much for joining us for the second tech panel today. For those of you who just come in the room, this is the AI panel. My name is Jim Boyle. I'm with the Office of Cooperative Research, and because this is a very complex topic, we needed to pick a moderator who has been an investor and an entrepreneur, and spent some time not just in life sciences and tech, but also thinking about software too. And for that, we were fortunate enough to get our friend Chris McLeod, who's a general partner at Elm Street, to join us because he's been all those things. So with that, I'm going to turn the floor over to Chris, who will introduce the topic.
Great. Thank you, Jim. And welcome to our second panel. Last year, you'll probably recall, we did a sort of a deep dive into blockchain and cryptocurrencies. And if you think about what's really hot this year, it's probably AI. I really am not an expert in AI, but I want to thank Rich Anderson for pulling together a great panel of experts. And Rich was recently at a tech overview session with Osage Partners, and they did a deep dive into PitchBook and the funding of new startups in tech. And over the last 15 months, they looked at the major VC firms, and out of 330 deals, about half of them went into either AI or machine learning startups. So it's really where the money's going this year. And if you look at just AI, I think about 96 out of the 330 went into AI, and 27 of those were university-based startups. So it's pretty clear that a lot of the leading research and a lot of the effort coming into AI is coming through universities, like Yale. So with that, what I'd like to do is have our panel introduce themselves. We're really fortunate to have with us today Martin Wattenberg from Google Brain. We've got Rania Khalif from IBM Watson Research. We've got with us BG Bhaskar, who's a CTO with 8BC, and Max Nova, who's the founder of Silvatira. So a good cross-section of investors, entrepreneurs, and leading major players in AI. So Mark, maybe you could tell us a little bit about what you're working on today and your role at Google, and then go down the line.
Sure, thank you very much. I'm delighted to be here. So I co-lead a research group inside of Google called PAIR, People Plus AI Research, and we're very interested in exploring the interplay between artificial intelligence and human intelligence. I want to illustrate some of the things we think about by talking about one recent project. So if you'll bear with me, I want to talk to you about earthquakes for a moment. So earthquakes, of course, big natural disaster, and made worse by the fact that if there's a large earthquake, it's typically followed by many small ones. And it's important to think about this for a bunch of reasons. It's a scientific mystery, of course, exactly where these aftershocks happen. There's also a huge humanitarian question that if you're trying to do disaster relief, where do you put a cell tower to restore cell service? If you knew there was an area where aftershocks would not happen, that would be very helpful. So as you can imagine, many scientists have thought about this question, where do aftershocks happen? There's sort of a standard method in the field, something called Coulomb failure stress, that is, it's something you can calculate and maybe get a sense has been validated in a bunch of papers that looked at individual earthquakes very closely. Okay, that's the background. Thank you for bearing with me. So a couple years ago, we invited a professor at Harvard, Brendan Mead, to our lab to work with us, and we're very interested in, can AI help humans do science better? And so with him, we started looking at this question of what happens when we try to predict aftershocks? And our research proceeded in 3 steps. Step 1 was to gather data. And in fact, there is a lot of data available. It turns out it hadn't really been collated in an easy-to-use form. It was grungy work. Our group did this. And so the first thing we did is we tested this baseline, this Coulomb failure stress baseline. Turned out it's not quite as bad as throwing darts at a dartboard or at a map, but it's really not very good. And in fact, with simple logistic regression on very simple metrics, you can even do better than it. So that was a surprise. And I think lesson 1 there is just dealing with data, the processes that go into making AI work can make people smarter. Second step was to actually try to do something more sophisticated than logistic regression. So we did this. We created a neural network, a deep network. It turned out it was not very large, maybe 70 neurons, far smaller than an image recognition network, and that blew past the state of the art. A very strong improvement above chance. Also interesting. So that's step 2. Computers, AI really can do very well. Step 3, though, was that we went back and looked at that network. We looked at what it was doing, and we were able to discover that essentially it was calculating something that was a physically meaningful quantity. So basically a quantity related to a certain stress tensor. And that, in turn, became a very scientifically intriguing object of study. Now the humans can learn from this network, and we can start to guess, maybe that will tell us something about the underlying physics. So I think this story illustrates a bunch of key lessons. The biggest one, by the way, is that humans are in control the whole time. This is a very human activity. It's not like computers are replacing anyone here. But there's a very virtuous cycle where we can, improve processes to get data ready. We can create models that do better than what humans had done before. And then we can learn from those models. And hopefully the cycle will continue. So with that example, over to Ron.
Go ahead, Rania.
Hi, my name is Rania Khalaf. I'm the Director of AI Platform and Runtimes at IBM Research. I lead an organization where we are really looking at research problems into scaling AI and putting it into production. So this involves multidisciplinary work around platforms, like how do you scale training, how do you do it across in the cloud, how do you do it across hybrid environments, and all the way up the stacks to what are the programming models, what are the tools, how do you take it from being a black card only a few people can do with a lot of resource to something more repeatable, easier, faster for more people to be able to safely do? And then how do you do this safely? So how do you understand what these models are doing? How do you debug them? How do you manage them once you have them? How do you know how good they are? And how do you put them in a way that they can be trusted by the applications and where they're being used? And then how do you manage them? So when do you update them? How do you know if they're misbehaving or they're seeing data they've never seen before where you know that they're not going to do well, and what do you do as a fallback plan so that you can infuse these models into business applications safely? And my team is interesting because it has a combination of people with different backgrounds. There are people with human-computer interaction backgrounds, distributed systems, programming languages, applied AI, and they all come together to tackle this because AI really is a full-stack problem, and it is also very much a human and machine problem, right? So.
Hi, thanks to Jim and his team for inviting me. It's great to be back on campus. My name is BG. Did a PhD in computer science from Yale many years ago. So always delighted to come back to my home. Currently, I'm a partner at an investment firm in Silicon Valley called 8VC. And I spent before that, before I started redistributing money, I was actually building stuff. I was early at Yahoo and LinkedIn, where I headed up data, and ran Yahoo's advertising exchange. Spent most of my career building technology teams and products around data. And then have come over to the investment side because I love working with entrepreneurs. At 8VC, we tend to focus on a few themes. One of them is what we call smart enterprise, because we feel a lot of legacy industries are getting revolutionized and disrupted due to easy access to public clouds, to big data technology, to mobile, to AI, which we will talk about today. More so, if you look at it, a lot of workflows in industry, which used to be completely manual or semi-automated, are becoming more and more automated. So we believe that a lot of legacy industries, all the way from financial services to logistics and transportation and manufacturing, will be going through a sea change over the next 5, 10, 15 years, and the change has already started by two means. One is workflows through human beings will increasingly get automated, and the data associated with the workflows will increasingly get ingested, transformed, and made into highly valuable data lakes. And then you can do stuff like business intelligence and AI on top of it. So that's kind of a focus of our fund. We're an early phase fund. We manage about $3 billion. And we also do a fair amount of investing in health IT, bio IT. I don't head that side up. I head up the enterprise software side. On the AI side, I'm probably the only one here who's not written code around AI, but I've had the pleasure of managing teams which were doing AI, both at Yahoo and at LinkedIn, and really looking forward to participating in the panel. Thank you so much.
All right, morning. I'm Max Nova. I was actually Yale 2012 doing computer science, and actually worked with Jim Boyle over there to start Sylvia Terra back when I was undergrad. And basically we use satellites to count trees, and that's basically the simplest version of what we do. But it's really important because where I come from, well, actually, where I come from is Kentucky. I'll always be from Louisville, Kentucky. But I'm living out in Stanford, California right now, and the state's constantly on fire, and it's sort of embarrassing. And the question is, well, how do we stop this from happening? And turns out that step one is actually knowing what's even out there. And so there's all these environmental challenges that are coming up that involve extraordinary amounts of data that humans just don't even have the bandwidth to process, but are important for us as a society to make informed decisions about and think through in a reasonable way. And AI is a reasonable way to get started on that problem, and that's what we're working on. So yeah, thanks.
Great. Well, the topic of the panel is, where will AI displace NI? And by that we mean natural intelligence. But before maybe we pose that specific question, I wanted to start off maybe with a quick story. I don't know, some of you probably have read Michael Lewis's book on Danny Kahneman and Amos Tversky called The Undoing Project. And in that, he relates the story of their research at the Oregon Research Institute back in the 70s, where they worked to try to say, could they do a better job diagnosing cancerous ulcers? And they talked to the doctors, and they put together a very simple model using 7 features, and equally weighted them, and used the trainings, or used the, tried to evaluate how this would do with 96 different patients. And they figured, they'd have to go into much more sophisticated refinements on the model. But, lo and behold, they found that that simple model had the same predictive accuracy as the doctors that they had used who had given them those 7 factors. What was really interesting was that they also interspersed in those 96 cases duplicates. So they had the same case in there twice. And what was quite interesting is where the errors and the inconsistency in a lot of the human predictions were actually every single doctor called the same case at least once, more than once, differently. So, we've got a situation here where arguably, AI can do better. And, I think, fast forward now 40 years, you're seeing, I think, the predictive algorithms have gotten a lot better. They're still maybe on a par with what doctors are doing. But what we're finding is actually if you combine the two, so that you don't just use AI, you just don't use natural intelligence, but you combine the two, you can take that predictive accuracy up significantly. And so I guess, the first question that we'll ask is, where do you see AI being adopted over the next 5 years? Currently it seems like, it's being used by Netflix to tell us, what movies to watch or where they're going to invest in making new entertainment. But my field in healthcare is it really hasn't penetrated. And there's a lot of other industries where AI, clearly has potential, but it's not yet being utilized. So the question to the panelists is, okay, where do you see it, being utilized and implemented over the next 5 years? Who wants to jump in first? I know.
Sure. So I think the answer is it'll be used all over, and it already is being used all over. I think a good way to think about this question is where will statistics be used? And I think already today we use statistics all the time. In some sense, AI is just another tool in the toolkit for statistics. That's a little bit of a boring answer. So let me give you a couple of others. Another answer is where there's an economic incentive. So my group thinks about medical applications, and there's a very interesting set of exchanges with doctors where if you talk to, say, pathologists versus ophthalmologists, how they feel about AI systems. And it turns out the same type of system and something that looks at an image and will make some sort of prediction. An ophthalmologist often is very enthusiastic about this thing, and a pathologist is not. And it's largely due to the economic incentives that the ophthalmologist would rather get on with the diagnosis and move on to surgery, say, whereas the pathologist, that's actually their job. So that's an issue that can come up, and I think the economic incentives are important. Another indication that there may be some sort of shift is I think there's a connection between outsourcing and AI. That one of the tricky things about moving to an AI prediction is that you have to get all of your ducks in a row. You have to be able to communicate to the machine in a very precise way what you're interested in. If you look historically at how outsourcing has worked, sometimes it's the same thing. If you're going to ask someone, halfway across the world to do a task, you have to put stuff in a very precise form and so forth. And that might be another place to look for possible areas where we'll see movement.
I also think there is a bit of a trend we're seeing where, if it's everywhere, we don't call it AI anymore. Like the speech reco now, there's Siri and Alexa and all these things, and also people use it for transcription of doctor visit, things like that. So when it becomes embedded in our daily lives, we'll think of it less as the magical AI thing that's in people's minds. However, I do think for cases where we are looking where these models maybe outperform humans or could replace a human decision or augment it, we are focusing mainly on where AI can really assist the human be more efficient, faster, give them a second opinion, show them why it came up with that level of data. Some of the places where we are seeing barriers to adoption really are also around trust if people don't understand why the model is saying something, they may not be able to take it either for regulatory reasons or because the ultimate decision maker is the one who's liable. Like, who are you going to go after if the decision is wrong, right? It can't be the algorithm. So the ultimate decision maker who's responsible for this needs some recourse about why the decision was made. So as those advances happen in the technology, I think we'll see more adoption in these other places. We do see some of our financial service customers, for example, where they're training a lot of models, but they're not deep learning models, but they're not putting them in production yet, right? Because of these kinds of concerns.
Max, you want to go first?
Sure. Yeah. So I've got a confession to make, actually, is that I'm not even really like a big tree hugger guy. I just love math and hate waste. And for me, that's actually why when I was an undergrad here at Yale, I mean, I thought I was going to be pre-med before Orgo beat it out of me. And, you know, so I was sitting there saying, like, well, what am I going to do with my life now? And my criteria was basically like, where is a place that could really benefit from a lot more quantitative sophistication than we have right now. And the forestry school threw great TGIF, thank God I'm a forester, Friday parties. And so I started hanging out with those guys. And the more I learned, the more I realized that, you know, I mean, forestry actually has a remarkable intellectual legacy of foundational statistical thinking and stuff, but it's really sort of stagnated over the last like 100 years, basically. But we're at a point now in our sort of overall global economic growth and everything where we need to start managing our landscape. We need to start managing our atmosphere. You know, there's only one planet, there's only one atmosphere. We need to be doing these things at enormous global or landscape scale. But it's tough because when it comes down to it, when you manage a forest, you manage a forest acre by acre. And so having the data to drive those decisions and then having the AI framework or the technical framework or whatever it is to balance between all these different values that we have and sort out, well, you know, California is about to have $1 billion over the next 5 years to try to make wildfires less of a thing. Where do they go? How do they do that? What's the most efficient way to do that? These are all really complex problems that we can start solving now with access to that data and with some of these more advanced AI type tools. Yeah, so that's personally what I'm really excited about, because it seems like something that's got to happen, and it's really just been in the last couple years where innovations in cloud computing and remote sensing and some of these things have enabled them, and so I think the next 5 years are going to be really transformative.
Yeah, DG, maybe I can get you, since you're an investor and you're part of the reason why all that money's going in. You know, when you're looking to invest in a company, you know, what is it that you would look to, you know, what is it you want to see, and why do you think that they're going to be successful with using AI?
Oh boy, I was going to act like I'm a real builder operator like I used to be, but that's fine. I'll put on my investor hat. For some of you might know, you know, this is an interesting campus to sit in and discuss AI. Yale Computer Science used to have, maybe still does, one of the best and most pioneering AI groups, which did fundamental work through the 60s, 70s, and 80s, which laid, along with MIT and Stanford, most of the foundations of modern AI, and Carnegie Mellon, so amazing. Very briefly, and I'll answer that question in a second, for us common people, where will AI be used? You know, three things are true AI can be used. And AI stands for stuff like machine learning, deep learning, computer vision, natural language processing. If there's enough data, if most of the data is clean, and the data has some implicit or explicit patterns in it, if those three things are true, you can use AI. So that's a pretty simple way of looking at it. Most of you have used AI a lot. You know, Amazon built one of the best recommendation engines in the industry way back in the late 90s. I used to spend a bunch of time there. And then everybody who's seen internet ads, maddening though they may be, has probably seen the most sophisticated use of machine learning, data cleansing, serving, and marketplace and mechanism design, all working together. It's pretty amazing, just to make you click on an ad, of which I'm also guilty. Coming to now putting on an investor hat, one of the things that we are noticing at 8VC is there are two kinds of AI companies who come to us. One is out of, you know, people of my background from the Facebooks and Googles and LinkedIns and Netflixes of the world, and you know, who are trying to build platforms around AI. And the whatever platform means, could be tooling, could be serving. From a business point of view, we don't believe platformized AI is a very ripe area for investment. We believe that most of the companies which are going to be successful in the startup space around AI are fundamentally, two things are true for them. One is they are verticalized. They're going after certain use cases, of which there is a large total addressable market, that people are willing to pay money for those use cases, either for efficiency purposes or, more importantly, for increasing business upside. So I would say that's one. The second part, as you start scratching the surface in these companies, is most of the AI that is used in these verticalized AI companies actually doesn't have to be that sophisticated. Most of them are actually data players. These verticalized AI companies will be hugely successful because today a lot of enterprise, private, public, semi-private data sources have been exposed. And this data can be brought into one place, cleaned up, and then you can build models on it. So we tend to look for those two things, and we tend to avoid platform companies, whatever they mean. I'll just keep it brief because I can speak for about a couple of hours on this, but that's a great question.
Great, thanks. I'd like to maybe dive in, Rania, a little bit on what you said about there being models available now, but not necessarily being applied. And I think one of the reluctances is that a lot of times people can't interpret necessarily what, have a hard time understanding the black box. And so, for some applications, natural language processing is not an issue, but now if we try to apply it to healthcare, I started with the example of 40 years ago. We just had our first AI-based diagnostic approved last year. And that was, as Martin pointed out, for ophthalmology, for detection of macular degeneration. So, how do we try to address the issue that I think is holding back AI for certain applications, which is this whole issue of interpretability?
You'll see that explainable AI is a very big field of study. There are several ways of this being approached in the research communities. Most of the big players are there. We actually do a workshop with Martin's team on this specific topic. And it's being approached from two angles. One angle is from the algorithmic angle. So you can try to see, can I take a neural network and create from it a decision tree that maybe looks a bit similar to it, so you can try to understand what it's doing? Or can I look, we recently had a paper on contrastive explanation, which was saying, instead of looking for what is there in the data, I tell you what's not there in the data, right? And maybe that's why it's, determining that something, the difference between, let's say, flu and a cold, right? It's the absence of a symptom versus the presence of something. And for other situations, it's really through things like visualization, where the mathematics is not there, but through human exploration of the space and what the thing is doing, you get a better understanding. This is a very active space. Some of the things we are able to understand. Some things we still have a long journey, and it's really a research topic still. So that's where I think, yeah.
Yeah, Martin, you certainly had experience there too.
Yeah, I think interpretability is this fascinating topic for a bunch of reasons. One is that I think it becomes a placeholder for many other concerns. What are we talking about when we talk about interpretability? I think sometimes it is literally trying to figure out what's going on inside neural networks, which I would actually say are increasingly not black boxes. We're getting more and better techniques, I think, for understanding what's going on. But very often, people have other concerns. Sometimes control is an issue. Our group actually just published a paper that was talking about a system aimed at pathologists, and it was a machine learning system in which we gave people sort of very fine-grained control over what the algorithm was doing, what it privileged. And while that was not interpretability, it sort of gave pathologists something that let them feel like they were partners. In fact, they were partners. I think there's another issue that goes on with interpretability. Frequently, what we're really doing when we create an ML algorithm and then when we put it into practice is we're creating new processes, new business processes, new maybe government processes if you're in a government, even new norms. And people want control over that. And frequently, one of the biggest concerns is contestability. It's less that they really want to ask why, but they want to be like, okay, I want to talk back. I want to have a dialogue and maybe even, say why this was wrong. And so all of these things, I think, are big concerns and fairly separate ones that need to be teased out. So I think interpretability is very important, but it's almost like a Pandora's box of things that we need to look at and sort of unpack that suitcase very carefully.
I just want to make one more comment too, that in some cases, just back to a bit this issue of trust, it is like a proxy, this interpretability thing, because so you also have to convince the person and relate it back to their practice, and how they were trained. So for example, if doctors have been trained in dermatology to tell if a mole is problematic because of this ABCD they follow, right? Like this, they look for these 4 things, asymmetry and things like this, right? If the algorithm is telling them that something looks like it could be malignant and it doesn't match up with the ABCD kind of training, or you can't relate what it's finding to that becomes harder for them to trust. So you look for other ways. Other ways could be, maybe it can show them examples of other cases that were later proven by biopsy to have been malignant that look like this mole, even though this mole doesn't look like what their training has shown them could be malignant. So those are some ways also of helping to bridge that gap, right, to increase trust.
Yeah, this is a really important topic. It's funny that you said we are actually, I don't know if it's the same company we are talking about, the approval that was given last year was for diabetic retinopathy, and so we are the ones who invested in the companies. Just want to put in a word. But yeah, it's fascinating. It's out of University of Iowa, and actually what we are discussing now is what I was actually working on it yesterday. So as Martin pointed out, so I'm hoping everybody here knows explainability to a certain extent, that if you have made a decision, you've built a model, how do you go back and see what exactly you did? How did you assign weights? How did you do feature selection? How did you even find training data, which is where a lot of bias lives, and I think you guys are experts in it, I'm not. For regulated industries, the first takeaway is, as an investor or as a builder, if an industry is regulated and you have to interact with the government first, algorithm design, data selection is as important as explainability. If you're giving a loan, if you're denying somebody a loan, or you're saying your insurance premium is this much, there has to be what we call auditable breadcrumbs. So governance audit goes hand in hand with explainability of AI. It turns out, and Martin knows a lot more about it than I do, in machine learning, explainability is a little bit easier because of the way machine learning workflows are set up. Deep learning is so much magic. I don't know if for the ones who are young here, in my generation, when we were in grad school, the most disrespected area of grad school was neural networks. This was 25. It was horribly disrespected, and now it's come back because of a few folks out of University of Montreal and Toronto, and then of course Google does everything before we are born, and then Google built TensorFlow. People are like, holy mackerel, it kind of works. But it's auditability, explainability, breadcrumbing is a little bit harder for neural nets for very technical reasons, which I completely don't understand. So I would say, make that point that auditability is important. And what looks like magic is actually not magic. So I think auditability is all about, so it goes all the way to what Martin said, that even the act of putting together teams and how you do software engineering has to change as you do more and more ubiquitous AI. I'm just talking about enterprises here, but please do understand that for those of you, and I'm not one of them, who have like Amazon Alexa at home and Google, whatever that's called, there's like AI happening all the time. But it's, sorry, I forgot.
Branding.
It was not. I'm just bad with names. But it's ultimately all about data running what we call on the edge. So much of our lives will be disrupted, right from traffic signals to self-driving cars to everything you do with very small devices on your body, because chips are much faster, memory is much more efficient, and you can push models to the edge. So yeah, I think there's a lot of plumbing needed to be built to make AI explainable.
Sure. So this was actually one of the biggest challenges in the early stages of our business is, here we are, some guys from Yale showing up in like, Jessup, Georgia with, a much better idea of what you got going on in your forest than you know. Oh, really? Tell me about that here, Yale boys. That's a huge question is when you show up and the numbers are different, whether it's AI or something else, like that becomes a very human problem. And, the level of sophistication of the people, people that in all these industries that are going to have a larger and larger AI component, they have a really long history of practice in almost all of these industries. They have an established way of doing things, and they're not experts in AI. They're not experts in stats, and trying to explain the math. We showed up and we're like, oh no, guys, it's okay. The math, here, let me show you how the math works. That's not the right way to do these things. That's not the level of explainability that needs to happen when it comes to the level of the individual practitioner. And it's a huge challenge actually for AI businesses of how do you bridge that gap? And we actually solved it. Like BG was saying, one of the most important levers you have is how you do your training data in the first place. And we were able to basically put in a what looks like a traditional forestry sample grid, which is something that everybody understands and is something that you don't need to explain. You can just say, like, listen, this is how you've always done it, and then we sort of fill in the gaps. Or like the numbers guys, this is another thing that I hadn't quite anticipated is you go to a big timber investment fund. Yale Endowment actually continues to heavily invest in timber, although Harvard's totally out now, but that's a different story. But but you go to them and you say, oh, hey, good news, I got a new top level number for you for what your portfolio is worth. They don't want to hear that. It could go up, it could go down. They really don't want that number to change. And so adapting your technology to say, like, okay, like we can roll with this top level number you have. We're just going to explain to you like sort of how this is distributed across your landscape. There's this whole other element of this that goes beyond just the technology that's such an important part of actually getting people to give you real dollars and actually changing the way they do their business practice that I hadn't understood when we started back a decade ago. So.
Oh, Max, I'm sure that the
I'm going to do like 30
the numbers to go up, but
well, that's not true because then it looks like they've been asleep at the wheel.
Given that my three comrades here actually do deep work and I'm the only one who does not, let me do a 1 second pop quiz. So the most sophisticated AI companies in Silicon Valley are all self-driving car companies, huge valuations. Any idea where the maximum headcount for these companies go to? Any idea? Which group in these companies has the most people, part-time or full-time?
legal, marketing, I've heard.
I'm sorry, I'm going to really disappoint you guys. It's in data labeling. Mm-hmm. Not in anything related to development. Most of these teams are sitting in Thailand, Malaysia, Bangladesh, rural India, and they're mostly part-time, and they're paid out. And there are huge numbers of people doing data labeling. It's very simple. Martin, I'm sure Google has figured out how not to even do that, but for most of us mere humans, that's how it is. Back to you, Chris. Yeah.
Well, maybe let's just stay on that topic a little bit because if data labeling is this important to AI, and you'll hear a lot of advances happening in China now, where they can inexpensively put armies to work. They can more quickly gather data than we can in the U.S. How do we compete in that environment? Obviously, we didn't prep this question.
I think I've taken a lot of bandwidth already. Why don't my comrades go first? I can speak to this for many days, so let me not go first.
So I think there are a couple of different ways to interpret that question. I think one is just how do we get data? There are lots of ways that you can get data, and very often you don't even need that much data on any particular problem. It's a myth that you have to have vast amounts of data for everything. So generally speaking, I feel like I'm not super worried. I do think that there is another question that's raised there about sort of norms around data collection, around privacy. And I think, this gets back to what I was saying around interpretability, where one thing we need to realize as we sort of forge ahead with this new technology is that we are not just making technology advance, that we really are sort of changing processes, changing norms, and we need to be very, very aware of that. One thing that certainly we think about a lot, and I'm guessing that probably everyone at this panel is the question of privacy, is how you gather data in a way that is not going to be harmful. Google actually has a set of AI principles, and I think that's really important. I don't think we want to compromise on those values.
Yeah, we have the AI principles. We also have an army of lawyers that are for any data issues. It's very hard. It's interesting in IBM. There's a lot that goes into, especially we are in the research arm. There's a lot that goes into what data you can and can't use, because a lot of data sets that a lot of people use, even the very famous ones like ImageNet, right? They're not really allowed for commercial use. So this has been very interesting about data, especially in GDPR and so on. So we won't get into that. Back to your question, we have a research lab in China and an IBM and some product teams there. So we collaborate with them a lot. But I think there are also advances in things like machine teaching and helping to speed up data labeling, sharing of data better. Those are things that can help, but I really do think that the companies, I agree with you, some things don't need a lot of data, but for some of these things that are getting close to human accuracy, you do. And in that, a lot of companies are at a big disadvantage. Like in our big enterprise clients, they don't have this massive amounts of labeled data, whereas if you're a consumer company, especially if you have free services, you are probably able to get a lot more of this data and use it as you will, as you wish, with a lot less checks and balances. So I think that's going to be the challenge in enterprise adoption for some machine learning models, or if you need to adapt it to your own problems and domains, learning with less data is a very active research topic as well. And that's where things like transfer learning, where someone learns on a much bigger public data set, and then you can come and bring just the slice that is for your industry or for your specific use case, becomes very, very interesting. And again, for startups, I think, back to your point about the verticals, I think if you're a startup with ML, you need to come in with, you need to have real data sets that you're starting with. Otherwise, it's really hard to prove that what you have is going to be useful. And a lot of the secret sauce is probably going to be an insights gained from that data that can differentiate between others.
I think the question was, how do we compete? I don't mean to, I think I caused some confusion. Data labeling is strictly blue-collar work in the context of data and AI. Whether it's good or bad is a separate issue, so I don't want to go into that. In terms of competition, I wouldn't put it, it's a very difficult question to ask because there are many questions around government policy, industrial espionage, open source projects that, some of us out of Facebook and LinkedIn and also Google, we basically produced, which is being used all over the world and is giving everybody a level playing field, which earlier did not, right? I think I will rather bring the attention around competition to training. Mm-hmm. So I know this was one of the topics in our prep session, which I personally feel really passionate about. And if you look at Yale, I was chatting with our friends Dan and Zhang, who head up the new data science program and the old CS program. These programs are not monolithic programs anymore. They are going to be the highest branching factor programs. There will be data science in biology, data science in manufacturing, data science in mechanical. Similarly for CS, it will not be a monolithic entity. So for AI, my view is fundamental coursework expansions and changes have to happen in academia, if not from high school, surely from college. And I don't think in my interactions with university presidents and governing tools, and I spent a fair bit of time with friends in academia, I think we're kind of behind there. And how is it going to change? Probably there has to be some public-private policy initiatives, and coursework has to expand. That's number one. And I would say that's a huge, huge, huge thing because people are going to live longer. So if we don't have people getting trained in fundamentals for white-collar jobs, then we'll have trouble in the economy. Second is, you will be in college or grad school for at most 4 to 8 years. You'll be in industry, you'll be working for 40 to 50 years. A much higher order bit is, how will employees be retrained? How will you keep your skills up to date? Anything around technology, almost every field of enterprises in anything all the way to government, to defense, all the way to industry will be impacted by data and AI. How do employees who are on the build side, decision-making side, business analysis side, keep up with their skills? I think these two are the more important problems, because with a repeatedly retrained workforce and with a fundamentally, data-aware, AI-aware undergrad group, I think many good things will happen in the future. That's what I would stress, more than competition between countries.
Right. And I meant it somewhat open-ended because, you don't want to be competing at the lowest level. And I think you bring out a good point, which is, we need to be thinking about how do we create the workforce we need to, tomorrow. Before we open up to questions from the audience, maybe just, one quick last question and observation is, we talked, it's been in the news a lot about, potentially bias entering into the algorithms that machine learning uses. There's now a proposed Algorithmic Accountability Act so that, these would get reviewed. It could be as simple as just, Facebook, how they are tailoring who sees what ads and whether or not certain classes are discriminated against in potential housing ads, for example. So that, how do you as practitioners, and with a vested interest in the acceptance of AI, try to guard against a backlash from society from these types of, what I'll call biases or inappropriate uses of AI, and what's your organization doing potentially to try to address that?
So bias and fairness in AI seems a bit simple, but it's really a very complex topic, and it's also a very human topic. So it's algorithmic and human together. We have released in one of our products some tools to help you, but one of the things that we have also been doing has been working with the open source community and with a combination of people with theoretical backgrounds and human-computer interactions and sociologists to create an open source tool called AI Fairness 360 and a web experience that brings together some of these bias detection and mitigation algorithms and mitigation techniques from other people and also some from IBM, right? So it's a toolkit that is trying to bring the state of the art together and helps you understand when things can be used and where. It is a very intricate topic. It's really not straightforward because it really depends, for example, on what you are trying to accomplish when you say you want to remove bias. Because if you are doing something like, say, you want to give all groups the same opportunity, you would do something different than if you want to accurately reflect the population that you have. Another thing, so this would be like, what kind of bias are you looking for? Would be something you select, which would lead you to a different algorithm to use. And then you need to help the people to understand, what does that mean, also make it consumable. Another thing I wanted to point out is often people say the algorithm is biased, but often it's the data that was biased. So if I come in and, I'm going to use some machine learning to help with my, let's say, salary practices going forward, if I was discriminating before because humans were making those decisions and they were subconsciously having cognitive bias that made them differentiate unfairly, then if I learn models from that data, guess what? Algorithm might be very fair, but the data itself is skewed. So it's not where I want to go. The historical data I have is not the future that I want to get to. So I have to figure out how I want to modify that to train the right model that can get me where I need to go.
How about bias? How about bias in trees, man?
I mean, that's my job, is to differentiate tree species all day long. But I don't have any serious thoughts about that. That's pretty far outside my wheelhouse. So.
There is tremendous discrimination in the world of trees. We should do something about it. I would say Chris is posing the question in the context of AI, but I think firstly, bias is a much deeper problem, right? I mean, in any diverse society which is continually being built and rebuilt, like the United States, our thought processes, moral and social values are the fundamental bedrock. I would say that's more important as as we get into positions of power in government, academia, or industry. So that's first. I'll give you guys an example about it. When I started my career in Silicon Valley in '95, and I quickly started leading people, there was not much discussion about diversity, confirmation bias, and stuff like that. I would say much later in my career, I would say even 2010 or so is when, once you went to a certain level of management, these things not only became questions that you were asked, you actually were expected to prepare for it. So I think I'm actually quite proud that is happening, and it's not happening because privileged people kind of sat and said, hey, let's make things more fair. It's because people who were not getting a level playing field, I mean, look at disparity between women's salaries and men's salaries, right? And people started making constructive noise, and with constructive noise, you start getting unbiased data, and you better do something about it, because as a society, USA is it's kind of an experiment. It's an experiment that is, that's why USA is an amazing example for the world. That how do you deal with diversity? How do you create a reasonably level playing field? How do you make sense of biases that are in history? So that's a whole different topic, but I want to make a note of it because AI does not exist independent of data, and data does not exist independent of people. So it's kind of important to know that. Coming to AI, I would say two things are important. As we already discussed in regulated industries, healthcare, insurance, loans, and so on and so forth, you will have to have governance and audits. So two things have to happen. One is, as you build products and software, there have to be tools built, which basically generate breadcrumbs. If you don't do it, you're host. It's not going to work. I mean, it's as simple as that, because people will lose trust in products and in governance. So that's number one. Number two is the process of decision making, which is the cultural aspect in industry. So those are the two things where, fighting bias in AI has to be reflected, very briefly. And we'd better do something about the trees.
So many trees.
Unless you have something, Martin, we can go for questions. Yeah, because I know Jim's going to 5 minutes. Good.
Yes, thank you. Fascinating talks. As quantum computing research progresses and assuming we reach a significant level of qubits, how do you see that impacting AI? Do you see a bottleneck with, say, algorithm design and processes, or do you see a quantum leap in AI?
Wow.
Short answer, I don't know. I will give you a slightly longer answer, which is that I would guess that the biggest advance will come from new architectures, something completely different maybe from neural networks. And people think about these all the time, but it's a fascinating question. I wish I knew more about the answer.
We do have a significant quantum program in research, and one of the questions that we are exploring also with our friends at MIT through a big collaboration we recently announced is really about this intersection of quantum and AI and what will it give you. So some things are AI for quantum, so can you use machine learning to improve the quantum machines themselves? But the other one is if you are going to do AI on quantum machines, when, what, how, and what is the impact going to be? Like you were saying, like would that change the algorithms fundamentally, or what would you do? So it's a very active area of research, but we're not quite there yet. There are some early papers on what you could do, but I think there's still a path to be forged. But it's a very interesting research topic for sure.
A lot more work to be done. Yeah. Go ahead.
So in terms of explainability, a lot of the example you gave for earthquakes, you actually uncovered underlying science. So what are the kind of mechanisms in place to, for example, in the diagnostics field, where you might, the underlying ways in which the AI determines whether the patient has disease or not, might actually fuel and help understand the underlying science and pathology of the disease. What mechanisms are in place to sort of reshare that with the research community? Because a lot of the companies are not going to have the bandwidth to really do that underlying basic research.
Yeah, great question. So one of the amazing things about the machine learning community today is that there's this incredible culture of publishing quickly. Like it's not even like people publish in conferences or journals. They publish on the archive, this non-peer-reviewed place to get stuff out as quickly as possible. And so a lot of the research that really comes to bear exactly on what you're saying, things like how would you interpret a prediction made on a medical image, is being published very quickly. So I think that's a very good state of affairs right now. I think the other thing that is really nice is there's a lot of tooling that's being released open source, and it's even becoming kind of a standard thing where if you want to publish at a conference, you'll be highly encouraged to release code that will let other people immediately re-implement what you've done or replicate. And we've certainly used that with other people's code. We publish a lot of our code and so forth. So I actually feel optimistic about that.
Thanks. Good question and observation. Go ahead.
5G, people talk about 5G. Will 5G enhance AI? No. 5G communication technology.
Short answer would be I don't know, but from what little I know, I mean, 5G is ultimately about bandwidth and reliability. So this just means you can push more data to the edge, you can push more complicated models to the edge. That's all I would say.
I'm going to jump in with a completely unrelated tree fact here, because I always force every audience to know one, is there are over 92 billion trees in the United States. We actually just counted them all as part of this Microsoft AI for Earth thing. So it's like 10 years of my life, like finally did it. But 92 billion is the number. So there you go.
All right. With that, I think let's call this to a close. And one quick, strong round of applause for this talented panel. Very good.
Thank you for doing this. From Yale, Jim. Hi. Thanks. Hi, Ron. It's nice to meet you. I love your comments. Both of you. Really helpful. Can I ask a favor? Videos, if that's okay? I think we have yours, Ronnie. I don't have that form for you. So what's your focus? You're ahead of the game. I was just talking about exactly the Red Hat. Thank you very much.
How we can actually get scientific principles out of data. So I wanted to ask you about that in public.
Myself and my colleagues at a couple of colleges, we read
Thanks for the support.
He's pretty excited. I enjoyed your presentation.
Yeah, so a lot of that is H1's mind. Yeah, where you guys voted.